Alright, so last section of 1.7 we started with learning about what proofs are and the idea of what a proof is. We did a homework assignment on it. We have an opportunity to practice the skill. This is going to be a year-long practice. It's like each proof has its own little personality to it. You're going to have to think through the process. What do I know? What mathematical processes have I learned in the past? They were challenging because of that. You're drawing on old information that you've learned in the past in order to do things. So you're also going to be getting some new information as we go along, and all the mathematical facts and properties and postulates and theorems and definitions, those things are all going to come into play when you do proofs. The main thing I like to do with a proof is I like to kind of see where the proof's starting me at and kind of think through the process before I write stuff down. And this is on a scratch sheet of paper usually. If I have to write anything down, or I'm at least going through the thought process in my brain of what I'm going to do. What I want to do on example 3, instead of a 2-column proof that I showed you on last week, I'm going to do a paragraph proof. It sounds just like what it is. We're going to prove it. We're going to write a paragraph. Sentences will sound something like this. This is true because of this. This is true because of that. And therefore this is true. Basically that's how it's going to sound. It's basically you take your statements and your reasons and put them into sentences. All right. And take a look at what we have here. It says angle 1 and angle 2 are supplementary, angle 2 and angle 3 are supplementary. Do we know what the word supplementary means? Anybody know?
Is that the one where they equal 90?
Nope. But you're on the right track.
They add to 180?
They add to 180, okay? Here's the easiest way to memorize that, or to, not memorize, but to know that. There are 2 words you're looking for, complementary and supplementary. All right, here's the other word, complementary. I'm going to write it on the board real quick. Okay. If you count the P's, supplementary has 2 P's, complementary has 1 P. More P's, more degrees. 1 P, 90 degrees, 2 P's, 180 degrees. So if you ever forget which one's which, easy way to memorize it. So we're told that angles are supplementary. So that means 1 and 2 add up to 180, right? And 2 and 3 add up to 180. Okay. And that happened quite a bit last week on the proof that we did. The practice proofs we have in the back, I'm thinking some of the proofs we had in the homework, where several things equal the same thing. And the very next step was to do what? We have there's substitution. If we have A is equal to C and B is equal to C, if we have 2 different things equal to the same thing, then A is equal to B, right? So I know because angle 1 and angle 2 are supplementary, they add up to 180. 2 and 3 are supplementary, they add up to 180. I know that 1 and 2 and 2 and 3 both add up to the same thing, therefore they add up to each other. That gets angle 1 and angle 3 into the same equation. We'll try to prove a congruence. And what we saw last week, to prove congruence, we first prove equality. We prove things are equal, and then by the definition of congruent angles, we can say they're congruent. So the thought process here is this. I'm going to start by stating my given information. I always start with my given information. The given information leads me to angle 1 and angle 2 add up to 180, 2 and 3 add up to 180, definition of supplementary angles. Then, once they're equal to the same thing, I set them equal to each other. At that point I got an equation, and at that point I can start messing around and getting to this point. So I've got my plan in place, now it's just a matter of putting it down on the paper. So step 1, I take my given information, which is all this stuff here, and we'll write, we are given angle 1 and angle 2 are supplementary. And angle 2 and angle 3 are supplementary. I usually write it like that, we are given, and then state what's given. You could also say whatever given information is given. I just think it's nicer to start a sentence with a word rather than a mathematical symbol. So if you start with we are given, you're starting with words. once again, they're naming angles with numbers here. If you have a picture associated with your problem, that you could refer to the angles with single objects like that instead of angle ABC, just a little bit less to write, a little bit easier to follow, I think. All right, the next thing that I would go with is once I know they're supplementary, we figured out supplementary means they add up to 180. That's the definition of supplementary angles. Definition of supplementary angle says two angles are supplementary if and only if their measures add up to 180. All right, so the definition itself of supplementary angle says exactly what we want to say. So I'd say, by the definition, of supplementary angles, comma, measure of angle 1 plus measure of angle 2 equals 180, and measure of angle 2 and plus measure of angle 3 equals 180. And again, that definition has supplied us with a couple equations, both containing what we want to prove. We want angle 1 and angle 3 to be congruent to each other. We need to get angle 1 and angle 3 into an equation. There's angle 1 in an equation, there's angle 3 in an equation. They're not in the same equation, but again, I don't care about that as much as just getting them into some equation. Because my overall goal with getting an equation is I usually have to use substitution to make that happen. Usually get a fact about one, a fact about the other. You can stick them together because of substitution. And the fact that this equation equals 180 and this equation equals 180, substitution simply says if two different things equal the same thing, then they equal each other. So we can say then that by substitution, measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. Notice I'm front-loading the reasons on these, and just, again, just for sentence structure, writing a nice sentence. I'm not starting with a mathematical symbol, by this, by that, whatever. It's just, I'm writing just a flowing sentence here as opposed to this plus this equals this because of substitution, whatever. Just, again, within the sentence you want to state the statement and the reason within the same sentence. So that's all that's going on there. So, what's next?
Where you, isn't it like substitution, like where you have to take out one of the two, like, what are the two angles?
Yeah, so you're saying substitution means subtraction.
Yeah.
Yeah, subtraction. All right, so we have an angle 2 on this side and an angle 2 on that side. I don't know how big angle 2 is, but its measure is what it is, right? So if it's 10, they're both 10. If it's 50, they're both 50. Whatever it is, the angle 2 on both sides is the same amount. The subtraction property of equality states that if you have an equation, which we do, if you have an equation, then you're allowed to subtract the same amount from both sides. That's what I want to do. So again, if-then statement, if you have an equation, something equals something is an equation, so the hypothesis has been satisfied, then you may subtract the same amount from both sides. We can conclude that subtracting angle 2 from both sides is legal. So I'm going to say by subtraction, property of equality, measure of angle 1 equals measure of angle 3. Notice I didn't show the math there. Okay, if a person's reading this proof and they see angle 1 and angle 2 equals angle 2 and angle 3, you said we subtracted and all of a sudden angle 2 disappeared. I think most readers would know this. Angle 2 got subtracted. So you don't have to actually work out the math there. You can mentally do it. But again, here's what the line above will be, and then we subtracted angle 2 from both sides, and we explained why we allowed to do it. Finally, we got the equality showing, right? Angle 1 and angle 2 have the same measure. We want to prove they're congruent. And again, the definition of congruent angle says two angles are congruent if and only if their measures are the same. Angle 1 equals angle 2. Measure of angle 1 equals measure of angle 2. Tells me the measures are the same, therefore the angles are congruent. So I can finally state maybe I can say so or therefore, whatever. Let's go so, angle 1 is congruent to angle 3 by definition. Of congruent angles. So this is a paragraph proof. It gets its name because you write a paragraph and you prove something. So, I mean, it's just basically writing down in words all the logical sequence of events that lead you to the fact that this given information leads to this specific fact. Okay, so the theorem that we've just proven is if you have two angles supplementary to the same angle, then those angles are congruent. In the process of doing that, we also said if we're given two angles supplementary to the same angle, the angles are also equal to each other. Okay, anything along the way that comes along the way in the proof is also a proven fact. So this is a pretty useful thing here. This happens a lot where things are supplementary to the same angle, so you can show some equality or congruence if necessary.